For the first time in the history of BigRep, we really tried to bring together the capabilities of the BigRep ONE in combination with materials. In this case, we have electronics embedded into the wall. We have sensor technology embedded in the wall, meaning that we really try to push the limits of what additive manufacturing is already capable today. For the first time, we were able to have 3D printed electronics inside a printed part. By putting the part back in, it will automatically communicate with the whole wall system. BigRep used its potential from dual extrusion technology to have an electrical conductive material. So by hand gesture, you can switch on and off lights, and you don't even have to touch them. This has a huge potential for all kinds of industrial use cases, like automotive and aerospace.
So the project we are showing here is about concrete cast. We developed with BigRep and Institute in Braunschweig together. So this is the first test. These are first samples that show the possibility of printing complex surfaces with the technology we already have. So basically that's done with the BigRep ONE. So we can go into 1 by 1 meter scale and build up a concrete cast for, let's say, concrete columns or special geometry that you can normally not fabricate in a traditional way on site. This is a very nice following project from the concrete cast project. It's a very detailed way of creating more complex inner structures within the concrete. We call it also the smart concrete. So in a way what we did, we used a filament, it's called a PVA, that is normally used as a support structure for the FDM pieces that we print on our printer. In this case, we transferred this material into a method of creating hollow or complex undercut structures within the concrete piece. So the possibility of making concrete geometries more smart and also use it to embed lighting or artificial lighting, wiring, or even natural light is much more possible now with this method than it used to be with the classical techniques.